Hi, I'm Timothy Brusella, and I'm discussing antidifferentiation with my Math 1325 class. And I'd stated two general antiderivative rules that I use a lot at this point. The antiderivative of a number by itself is a number times x plus c. And the antiderivative of x to the power in terms of x. You're undoing that power rule for differentiation. Normally we multiply the exponent by the coefficient and then subtract 1 to get the new exponent. We're performing the opposite operation in the opposite order. So the first thing we do, we add 1 to get the new exponent, and then we divide. I printed out some problems from my math lab, and we had worked through on the first video, we worked through number 5. Now we're picking up at number 6 here, which I've written down nicely for us. We know what to do when we run into antiderivatives to functions containing radicals, whether we're differentiating or anti-differentiating. We're going to have to rewrite it using an exponent, that cube root of x, that's x to the 1/3 plus x to the 1/4 in terms of x. So now we're going to use this rule right here. Add 1 to get the new exponent, divide by the new exponent. So we're going to add 1. Divide by the new exponent plus the x to the 1/4. Add 1, x to the 1/4 plus 1, divide by the new exponent, and don't forget your plus c. Oh, that orange doesn't want to show, does it? So that's 1/3 plus 3/3, that's x to the 4/3, divided by 4/3, plus, hopefully this orange is showing okay on the camera. I'm having trouble seeing it here, but so 1/4 plus 1, that's 1/4 plus 4/4. So what's the exponent going to be there? It's going to be x to the, what's the exponent going to be? 5/4. I agree. Divide by 5/4 plus my constant c. How will I simplify this? It's a compound fraction. I like to multiply above and below by the minor denominator. The minor denominator is 3, so we're going to multiply above and below by 3. That gives us a 3x to the 4/3 all divided by 4 plus multiply above and below by 4. So we have a 4x to the 5/4 divided by, what are we going to have down here? I agree with the 5 plus c for my final answer. And realize that that is the same. I should mention this, that multiplying by 3 and dividing by 4, if we wanted to write that as a number times x, this would be the same answer, okay? Just as correct. 3/4 times x to the 4/3 plus 4/5 times x to the 5/4 plus my constant c. Either one of these purple boxed in answers would be considered correct. Okay. Let's move up. We can anti-differentiate a number by itself. We can antidifferentiate a variable to a power, but at this point, that's all we can antidifferentiate. So that 1 over x to the 11th, we need to rewrite that as x to a power, and we've certainly done that enough this semester. When we were differentiating, 1 over x to the 11 is the same thing as x to the negative 11, and then we still have that minus x to the 11th minus 1/8 dx. But that is an x to the negative 11 there at the first term. So, antidifferentiating x to the negative 11, add 1. Negative 11 plus 1 is negative 10. Divide by negative 10. Minus x to the positive 11. Add 1. 11 plus 1, that gives us a 12. Divide by 12. The constant term, minus 1/8. That's a minus 1/8. What do we need to do there? We stick on an x plus my constant c. And let's see. Why don't we write it, since this is a variable times x, I think I'll do the same thing for the other two terms. That's a positive 1 times divided by a negative 10. So that would be a negative 1/10 x to the negative 10 minus, that's a 1/12 x to the 12th minus 1/8 x plus my constant c. I'm not sure why I'm changing colors so many times there. Then it just looks good. For my final answer, any questions there? Now suppose I didn't want a negative exponent in this first term. I'm sure my math lab will take it just like that. But since the first term didn't have a negative exponent, the first term's exponent was positive. If you wanted to write this one with a positive exponent, the final answer, you would say, pick up the x to the negative 10, move it down, that becomes 10x to the positive 10. We can change that negative on the exponent to positive 10, but you can't get rid of the negative on the coefficient. You're just stuck with that. And then all the others would still stay the same. They already have positive exponents. So I would say either of these two boxed in answers, either one of those, I'll say or. And here's another one. 12x plus 5 quantity squared. Well, we'll see a way of, in the next homework assignment, we'll see a way of anti-differentiating functions to powers. But at this point, we don't have that method. All we can anti-differentiate is sums and differences of constant terms and powers of x. So I would square that 12x plus 5 and write it twice and FOIL it out. That'll give you a 144x squared plus a 120x plus 25. Once you realize you can do that, the rest of this should fall out pretty quickly. You can say, okay, okay, 144x squared, we're going to have to add 1, that becomes an x cubed, divide by 3, plus a 120. What exponent's going to go on this x? We're anti-differentiating that 120x. What exponent's going to go right here? That's like a 1 plus 1. I agree with the 2. Divide by 2. Plus, what else do we have here? We have a 25x and our constant term. So 144 divided by 3 is that a 48? So we have a 48x cubed plus 120 divided by 2. That should be a 60x squared plus 25x plus c. For my final answer. And let's see what else we have. I haven't written anything else down here. Let's see. Here's number 11. Let's do this one. We're going to do number 11. I want me to evaluate this indefinite integral. 1 over 8x to the 7 dx. Well, we got to get rid of that. We can't anti-differentiate it with that x there. All we can anti-differentiate is a number times x to a power, not a number divided by x to a power. So we're going to rewrite that as x to the what exponent? Pick that x to the 7th up, move it out of the denominator. That becomes a negative 7 dx. And now, anti-differentiating, we have a 1/8 x, negative 7 plus 1. What's the exponent we're going to have on x? Negative 7 plus 1 is a negative 6. Divide by negative 6. Plus my constant c. So that's a 1 times x to the negative 6, that's just an x to the negative 6 over 8 times negative 6 is a negative 48 plus my constant c. I don't see a coefficient in that numerator, so we assume it's a 1. 1 divided by negative 48, that's a negative 1 over 48. I'm going to pick that x to the negative 6 up, move it down to the denominator, make it an x to the positive 6 plus c. I decided I would write my antiderivative the same way the derivative was originally written, with the variable in the denominator with a positive exponent. Although I'm sure that my math lab would accept something like 1 divided by negative 48 is a negative 1/48 x to the negative 6 plus c. One or the other. I sort of like this form here because it's consistent with the form that the original function, the derivative they gave us was written in. Let's see. This one's on that list of problems I printed out. Let's see. Here are 2 others that we'll do. Let's see here. Here are 2 others we're going to do. Let's do 13 and 14, okay? Let's do 13 and 14. The antiderivative of 3x squared, let's see, that's number 13. The antiderivative of 3x squared, oh, how did this one get here? Oh, I must have just been wanting to be nice to the students, I guess. At this point, this should seem pretty easy. You have the 3x, what's the new exponent? 2 plus 1 is 3, divide by 3, plus my constant c. And that cleans up very nicely just to x cubed plus c. And one more, number 14. The antiderivative of 6x plus 5 dx. Anti-differentiating 6x, that becomes a 6x. What power do we have here? Squared divided by 2 plus 5, stick on an x, plus c. And that reduces just to 3x squared plus 5x plus c. And how about we do some word problems? Let's do some word problems. Okay, we've already done 11, 13, and 14. Look at number 12. Find the cost function if the marginal cost function is given by c prime of x equals x to the 1/2 plus 9, and 4 units cost $78. They're giving us the marginal cost function. That means that's the derivative. They're even telling us c prime. They want us to go back to the cost function. The problem with this process, when you're given a derivative and you're going back to the original function, you have that plus c stuck on each time. Your constant that you have. Now, if your boss tells you, find me a cost function to model this thing, and you go and tell them, well, it's going to be this, plus this constant c here, so our costs will be either there'll be 10 million plus a constant c. That c could be a 40 million or it could be a $12. I think you'd have major problems there with your boss giving them this function that's just in terms of with a constant. So they have to give us some additional information that we can use in order to determine that constant of integration. So this is number 12. They give us the cost function's derivative. The marginal cost function is x to the 1/2 plus 9. So we're going to go back to the cost function. To go backwards, we have to anti-differentiate x to the 1/2 plus 9 in terms of x. Well, the antiderivative of x to the 1/2, 1/2 plus 1, that becomes a 3/2, divide by 3/2, plus the antiderivative of 9 is 9x, plus, normally what letter do I use for my constant of integration that I have to stick on there? A c, but we're already using a c for cost, so I'm not going to do that. I think I'll use a k for constant. Multiplying above and below by 2, we get, multiplying above and below by 2, we get that my cost function is 2x to the 3/2 all over, what have we got down here? We have a 3 plus a 9x plus my constant k. And this is what I was talking about. Go tell your boss, well, the cost function, our total cost is going to be $10 million plus k. K could be anything. K could be 100 billion. K could be 4 cents. But it could be anything. I don't think your boss would like that. So, they gave us this additional information here. 4 units cost $78. That means when x is equal to 4, the cost, c of x, is 78. So, plug in, when x equals 4, c of x is equal to 78. So you're going to plug in 78 for c of x equals 2 times 4 to the 3 halves all over 3 plus 9 times 4 plus my constant k. Let's see. 4 to the 3 halves. The square root of 4 is 2. 2 cubed is 8 times 2. Let's see, that's 16 thirds plus 36 plus my constant k. And let's see, we have a 78. I guess we could subtract 36 from both sides. Oh, let's see. Yeah, we have 78 minus 16 thirds minus 36. I'm getting that k by itself. 78 minus 36, we know that that's 42. Oh, wait a minute. 42 minus 16 thirds. Is that giving me a k value of 110 thirds? So we now know what our cost function is. There's the k value. So my final answer, the cost function, is 2x to the 3 halves all over 3 plus 9x, is this visible? Let me push it up some, plus 9x plus 110 thirds. For my final answer. For the word problems involving antiderivatives, they'll give you the derivative and you'll have to antidifferentiate to find the original function. But when you do, you're stuck with that constant of integration. In order to find the exact value of that constant, they have to give you the values for one specific point in time. Here they told us that 4 units cost $78. So you plug in 4 for x, 78 for c of x, solve for k, and our constant of integration turned out to be 110 thirds. Okay. And okay, I think I'll take a break right now. Maybe I'll come back and do another word problem in a little bit. Bye-bye.